Welcome back to mini video series on fraction. So in this video, let's take a look at prime factorization and finding all the factors of a number. I think I kind of left this part out, but I can definitely talk a little bit about it as well. So let's take a look at the wording prime number. Okay, a prime number is referring to a number that has exactly two factors, one in itself. Okay, so the one that is being highlighted in yellow here are your prime numbers from one. So within from number 1 through 50, these are the list of your prime numbers. The popular ones that we normally use are 2, 3, 5, 7, 11, maybe sometimes 13. Okay, those are the commonly used ones. So if you watch the video on divisibility, and you already see that we already talk about divisibility by 2, by 3, by 5. Okay, very similar as what we're doing here. Those divisibility rules also can be correlated with the prime factorization, okay, when it comes to reducing or simplifying fractions. Okay, so just remember the number 1 is neither prime number nor a composite number. Okay, composite number simply means a number that have more than two factors. So 1 is not a prime number because 1 is only 1 times 1. So that does not classify itself as a prime number. All right, so let me show you how to do prime factorization. Again, the reason why we need to know prime factorization because it does help when it comes to reducing or simplifying fractions, especially for numbers that we normally don't tend to recognize or numbers that are not on the multiplication table that we normally don't encounter. So I'm going to start you off with an easy one, like a number 20. There are a couple different ways to write this out. Some teachers teaches the tree methods. Okay, so you put a 20 up here, and then you get yourself a couple branch. Find me a prime number that can go into 20. So remember now, we just want prime numbers. So if you know your multiplication table very well, you know 2 can go into 20, 4 can go into 20, 5 can go into 20, 10 can go into 20. But since I only want prime numbers, I'm just going to start out with the prime number 2 first. I know 2 can go into 20 10 times. All right. So 10 is not a prime number, so I'm going to break apart the 10. 10, I can use another 2, go into 10 5 times. So both of the 2 and the 5 I just wrote are prime numbers. So the prime numbers that make up the number 20 are 2, 2, and 5. So basically what we're saying is the number 20 is made out of 2 times 2 times 5. So it's made out of these three prime numbers multiplied together. Another way you might sing is this thing called the alternative way, or I call it the upside down division. So on the outside of my box here, I will find me a prime number that can go into 20. So rather than using 2 like I just did start out with, I'm going to use a 5 start out with. 5 can go into 20 4 times. So now I got myself a 4 here. So by looking at this 4, find me a prime number on the outside go into 4 evenly. So that will be using a 2. 2 can go into 4 2 times. Since 2 down here is a prime number, only 2 can go into 2 one time. So when you wrote a 1 down here, that's when you stop. And all these numbers on the side are the prime numbers that makes up 20. So you get the same answer, 2 times 2 times 5. All right, 63. 63. So if I use the divisibility by 3, 6 plus 3 is 9. 3 can go into 9, so that means 3 can definitely go into my 63. So that means the first prime number I'm going to use to go into 63 will be 3. So I like the upside down division way. All right, 3 go into 63. Let's see how many times. I know 3 can go into 6 2 times, which is a 6. Long division, I subtract, so that becomes 0. Bring down the 3. 3 go into 3 1 time. So 3 will go into 63 21 times. If you know your multiplication table pretty well, you know 3 can go into 21 or 7 can go into 21. So you can use either number, it will be fine. 3 go into 21 7 times. And it turns out 7 is also a prime number. So that means only 7 can go into 7 one time. So when I wrote that 1 down there, that's when I stop. So these numbers on the side are my prime numbers that makes up the 63. So the prime numbers that make up 63 are 3 times 3 times 7. Okay? Again, learning about prime factorization can definitely help us when it comes to reducing or simplifying fractions. Let's go back up to the very top. All right. Finding all the factors of a number simply means listing all the factors multiplied, giving my number back. So let me just kind of write it out this way. Find all the factors. Okay, I'm going to go to another page. For example, find all the factors, okay, of the following number. So let's do 20 again, like I had earlier. All the factor makes up 20. So what you do is you start out with 1. 20 is, let me put it right here. We know 20 is always 1 times 20. All right, after 1, you try with 2. We know 2 can go into 20 because 20 ends in 0. 2 go into 20 10 times. Okay, try with 3. Well, by the divisibility by 3, it tells me 3 cannot go into 20. Or if you know your multiplication table pretty well, you know 3 cannot go into 20. So let's try 4. So right now what I'm doing is listing all the numbers that can go into 20. 4 will go into 20 about 5 times. All right, so after I try 5, let me erase this, okay? After I try with 4, I try with 5. Well, I know 5 can go into 20 4 times. So since I already wrote a 5 on the previous line, that means what? That means I'm beginning to repeat myself with the factors. So when you find yourself repeating yourself with the same factor you already wrote, that's how you know that's the end of it. So all the factors or all the numbers that can go into 20 are 1, 2, 4, 5, 10, and 20 itself. Okay. Same thing for the 63 that I showed an example of. Find all the factors of 63. So I'm going to start out with 63 here. 63 equal to, well, I know 63 is 1 times itself. All right. I know 2 cannot go into 63 by the divisibility by 2. Earlier we saw 3 can go into 63 21 times. All right. 4 cannot go into 63 because earlier in the divisibility video, I show you 4 can go into 64, so it cannot really go into 63. 5 cannot go into 63 because it does not end in 0 or 5. 6 cannot go into 63. In order for 6 to go into 63, it got to be, well, then 3 got to go into it, so it's 2 got to go into it. 7. If you know your multiplication table well, 7 go into 63, that will be 9 times. 8 does not go into 63. So the next one I check after 8 is 9. Well, I know 9 can go into it. So since I'm repeating myself with the number I already wrote down, so that's the end of it. So all the numbers that can go into 63 are 1, 3, 7, 9, 21, and 63. Okay, that's what I mean by finding all the factors of a number. So both techniques can definitely help us simplifying or reducing fraction. All right, that will conclude this video. Thank you for watching.